Just my mouse does not have power. So, okay, Omer, you can start, please.
Okay. So my name is Umair, and I'm working at NTNU Olesund in the faculty of IE at Department of ICT and Natural Sciences. And today I'm going to talk about prognostic maintenance of road infrastructure. Uh, Currently, I'm working on creating digital twins for smart cities. This project, which I'm going to discuss, is basically not related to what I'm proposed to do in my PhD, but during looking at the content of the course which Ibrahim has offered, so I will use some deep learning models and apply those models on the roads infrastructure data. So this data comes from NPRA, which is uh, a Norwegian department. Uh, we can call NPRA, Norwegian Public Road Administration.
Yeah, it's
So
a by norsk, it's a Staten Varvassen.
uh, yeah, so we have that data from NPRA, and yeah, let's start with that. Okay, so what is actually the prognostics maintenance? We can call it as a condition-based maintenance or predictive maintenance or simply prognostics. So in this, we have a life cycle of, for example, roads or some machines or everything. So we can apply the prognostic maintenance on any kind of data. So in this, we have roads data, and the data is image data. So we will apply for PM on the image data set, and we use it to know the condition of equipment and to plan and perform maintenance accordingly before a critical failure. Uh, so what I'm gonna do, I have defined some research questions for this task. That how should we predict anomalies from roads images, or how should we select an efficient model for anomaly detection, or how should we apply prognostic and maintenance based on deep learning models. So these are the basic three research questions that I have defined for what I'm proposed to do in this project. Then the goal is to explore the use of machine learning to improve the maintenance efficiency of the roads network, and to learn different deep learning models and apply it on this prognostics task. And the dataset, we actually have the dataset from the Norwegian department, and we have classified it into two types, which is, well, first one is the vecdesk and the other one is P18. So I will not go into the description of this dataset, and I'm planning to submit this work in a conference or a journal. uh, Basically, I have started working on this. Uh, so this is my proposed pipeline, in which if you can look at this input image, so this is the damaged road. We can call it a damaged road. So in this, I want to apply convolution neural network for feature extraction. So at this step, I want to apply VGG16 or ResNet. So I think based on the current literature, VGG16 is a promising network that we can apply. So Ibrahim maybe also is going to teach us at some time about some convolution neural networks and what is VGG 16 and 19. But it has 16 layers. So rather I can apply ResNet 50, but the thing is I'm just gonna start my experiments. So I will check the which one would be beneficial for this task, and then I'm gonna uh, collect some feature maps after feature extraction part. And then here I have a prediction network where I want to apply faster RCNN But anyhow, we can also use original proposal in RPN, or we can also get some bounding boxes for the these damages or cracks. So actually, people define in civil engineering areas, they define it as a damage or cracks or potholes. So it has different types. So based on different types and the severity levels, I want to classify the severity of these damages in three parts. For example, a high damage, highly damaged, or medium level, or low level. So this is not my output, but I want to get an output where I can uh, define or devise this, that this is highly damaged, this is medium level damage, or this is low level damage. So it can be beneficial for them who are working in NPRA department to check whether they should go for a high level or medium level or low level damaged parts. And they can also look at this. So this is what I want to do. And I have started working on it, and maybe at the end of this course, I'll be able to publish at least a paper in a conference or a journal. So this is what I have planned to do in this coursework. So if you guys have any questions, you may ask. But I have already told that this is not my PhD project. This is this course's project. But I have worked on image processing and computer vision tasks in my master's. So I think it could be helpful for me to keep learning on deep learning things. So that's what I want to do.
Yeah. Thank you very much, Omir. I have a question about remaining useful life. Is it possible to combine those cracks? Because in each, maybe in each meter or in each section, we will have multiple cracks. Is it possible to combine those cracks and define a variable describing remaining useful life of road? So we can have one number. Um,
So, regarding the remaining useful life of this, because some people have applied single shot detector on detecting these damages. So they only have detected these damages, but they haven't applied a task of using remaining useful life. For example, how should we learn that what is the remaining life of this damage? Uh, anyhow, as you know, we have worked on something health prognostics and health management. So
mhm.
we can use that PHM work to check the remaining useful life of these roads. So we can also combine RUL on this at this faster RCNN. And after this, if we have detected efficiently, then we can also apply the remaining useful life. Uh, Let me check.
But, but
Uh,
but but in this case, you need someone to say that okay, remaining useful life in this case it's 80%, it's 60%. So we need also to get some labeled data, right? It will be prediction. We need to get
yes.
someone to regression problem. We need someone to say okay, for each image, the remaining useful life should be 80%, 60%, and so on.
Yeah. So for that, there is a lab in Japan. They are working on that. So maybe I can take help from their code to check the remaining useful life of this. But beside this, we also need to validate this.
Mhm.
And for validation, maybe I will need help from a civil engineering or infrastructure department. So I think Ali Reza, I have searched him. He has worked on. He is working in civil engineering department. So maybe at the final stages, I may seek help from him about validation and something.
Okay. So Ali, do you have any comment?
I actually, I am in civil engineering, but my expertise in telecommunication systems. So maybe you can find other people here. You are welcome to come here if you can to talk with other people who can help you.
Mhm. Yeah, thank you very much. Thank you very much, Ali. Yeah, thank you very much, Omar, for nice presentation.
Thank you. Thank you.
Thank you. Do we have any other presentations for today? We have 9 minutes, 10 minutes.
I have a presentation. I can make it.
Okay, thank you very much. Yeah.
All right.
Is it okay for you?
Propose to disable participant screen sharing.
Yes. It's disabled?
Yeah.
Okay. Yes.
All right. Now it's working, I think. Can you see my screen?
Yes. Yes.
All right. Yes. My name is Johan. I'm a PhD candidate here at Ålesund at the Department of Ocean Operation and Civil Engineering. Right. And my background, my PhD project, it's called, well, the working title of Data-Driven Scenario Forecasting for Smart Ports, where the main objective is to investigate and establish a local simulation model for operational forecasting of mainly wind and waves in port regions. And for this, we're going to use the port of Ålesund as a case study for the entire project. And the idea of this forecast model is to work as a decision support for demanding conditions and operations, to be able to give information for approaching vessels so that they're coming into the port, or if you have a different kind of port operation as well. And a few system requirements for this is that we want to collect and digest environmental data, and for this we need sensors both inside the harbor and outside the harbor. And we also, based on this, then we want to produce a short-term forecast. For this, the idea is to have a simulation model. Like my background is not within machine learning and so on. I have a background in applied mechanics, like fluid mechanics, computational fluid mechanics and so on. So that's the main idea, but I want to test this course and see what I can learn from this.
Yeah.
Based on this short-term forecast, then we want to give a recommendation how to act and take into account the planned operation and what's the best action based on the forecast with the planned operation. And so for forecast approaches, we have 3 different main kinds. We have these physics-based numerical simulations, like weather forecasts, usually based on these fluid mechanics. And then we have these statistical methods. We have the pure statistics, or these machine learning and neural network based, and we also have the hybrid based. So here is like a simple project methodology that I was initially thinking about, that we have the domain, we make it into these numerical models and so on. But for this course, I want to try the approach of machine learning instead. I want to learn that. So I have some previous related work from last semester where we did a case study in our wave tank here in Ålesund. Looks like this, where we have a 10-meter long wave tank where we can generate the waves in different modes and different settings. And we can measure them by measuring...
We don't have your voice. I think
Yeah,
the other microphones might...
If it's not a problem, could you switch this place so we see entire presentation, because it's really difficult to read images.
I'm sharing the wrong screen, maybe.
Yeah.
All right, sorry. Let me see.
Yeah, at the top, display settings, and then just, yeah.
Is this better?
Yep, great, thanks.
All right, and my voice is okay?
Yeah, it's okay.
All right, sorry. Yeah, so this is the setup we have in our lab. And I used this last semester to extract some. Can I click here? Yes. All right. So we get some time series from the surface elevation. Basically raw data that I used
Your
to.
voice is on again, I think. It might be some other microphones are on, and it's because of it.
All right. So my voice is breaking, or what's the problem?
Your voice is just on and off.
Yeah,
constant.
cutting out a bit. I think it's like you putting your hand over the microphone or something like that. Yeah.
I'm using the laptop mic. Maybe that's the issue. Is it better now? I try to change. Do you hear me better now?
It's fine now.
All right. I can try to put my headphones on instead. Doesn't seem to work.
Yeah, it works.
All right, is my sound really bad, or should I continue, or?
Yeah, you just continue, please.
All right, then I continue. All right, so where were we? Yes, okay, so we had this time series of the wave that I want to predict, and for this, we have a bunch of wave theories that, yeah, basically are analytic equations that describe this sea surface elevation, or the water wave surface elevation. And for this, I use simple least squares to fit these models to the data that I had, and I got not that good results. So I want to continue on this, but I want to try instead to use this machine learning approaches instead of just simple least square, nonlinear least squares. And so my idea for the project is to use more sensors. I want to use basically 2 or 3 sensors or something like that. And I have 3 different ideas. I want to predict the output waves based on the settings of the wave flap motion. So we have this wave flap that generates the motion, and that we control by a simple sinusoidal harmonic motion, and that generates waves. But that's not exactly the same motion as the wave that we get. So we can, there's some sort of transfer function that we want. That's one idea, to predict that how the waves that we generate are related to this wave flap motion. Or the other one is to predict the pure wave motion is downstream based on the measured data upstream. So if we measure some data here, I want to be able to predict how will the waves actually look down here. That's one option. And then I was thinking also that to continue on the previous track that I had, just find the equation, the partial differential equation that best describes the specific waves that we generate in our test tank. And this is also some sort of regression problem. I read a bit on this sparse regression that you could use for this. Yeah. Anyhow, the research questions, no matter which one of these I choose, it will be just look at the state of the art, what methods are used within machine learning or neural networks to predict the time series of water waves and to see how these perform in our test case. And also this one is maybe the most interesting one for me then is how robust are these methods to environmental changes? So what if I would put in some object in between here, like that affects the whole physics of the domain? How well do the model perform in that case? Yeah. And here I tried to draw up a simplified flow chart for what I want to do in this predicting the waves downstream. So we get some information from the first sensor that's located at the position X1 and Y1, that's upstream. And then we get the surface elevation. As the raw data, we need to do some pre-processing. From this, we can get the wave period and the wave height. We feed this into some sort of regression model where we need to classify the wave based on some parameters, the steepness, the shallowness, the skewness. And from that, we might be able to decide which theory that best applies for this wave that we measured, and then we can predict the time series. And then we could get an estimation of the surface elevation, both in the future of time, but maybe also at a different location. And then we have the sensor that's further downstream. We use that information to validate, is this a good prediction or not? Yeah, so that's the basic idea. And I have been thinking about these data collections. So we have the wave tank, right? We use that, but we haven't used multiple sensors or wave sensors before. So we have to install that. And we have the sensors right now, but we haven't installed them. And I'm not sure how much time it will take to collect the data, install the sensors, calibrate them, and see that it's working fine. So that's one idea, to use the real data by installing more sensors. The other thing is that we have a working CFD model, a numerical model that we can run simulations just by now, running them and collect data from this synthetic model then. But they are also very time consuming. One of these simulations takes up to 5-10 hours, depending on how long time series you want them. And then you also have the issues of computational accuracy and reliability when you use a numerical model instead of the real physical experimental model. Yeah, but that's basically my idea for a project. Yeah.
Thank you very much. This is a very, very good work and a very nice idea. So I thought that you have already some data from the fish, from the tank, wave tank.
Yeah, I have from the previous test, but then we only have one sensor for that, so it's only information from one location at the tank.
Mm-hmm.
Two locations. Right?
Yeah, yeah. Yes. Any questions from other people, please? You can just raise your hand or ask it directly, please. Okay, I cannot hear anything. Yes. Any questions? Mingetao, Irini, Matea? No? Okay. So thank you very much, Johan, for this nice presentation, and I hope that by the end of the course. But I guess now you can start maybe. We have studied, I mean, so far, perceptrons and multi-layer perceptron. So it should be possible now really to start working. So it's for everyone, in fact, to start work with your data, try to polish your data, display your data, visualize it, and try to select a baseline model. You don't need to go for deep learning stuff at the moment. So you can start now with the models which we have tested, multi-layer perceptron from Keras, from sklearn, some perceptrons. So we can start now, at least some of us who has data already, so you can start experimenting by some of those models. And with time, you can add more models and make good comparisons between algorithms. So thank you very much for today, and we will meet again next week. Yeah.
Thank you. Bye.
Thank you very much. Bye-bye. Bye-bye.